roughly an hour and a half is we're going to have David on some of the work that they've done on metadata extraction in the journals context. And then I'm going to talk a little bit about sort of connecting the morning and sort of what's coming in terms of the life cycle and how some of these techniques are manifesting in specific use cases. And then Aaron's going to start drilling in and providing concrete examples of how this is all enabled from a technology perspective.
Okay. This talk was prepared at relatively short notice, so I apologize for that. As I mentioned in an earlier talk of this meeting, the original design for the way that the log system disseminated its content was totally transparent. We used proxy. This turned out to be not a good idea for a number of reasons, but the chief one was that it was very difficult to get people to pay for a system that delivered no visible value. So we had to augment the original design, acting as a web proxy, with a Wayback Machine-like ability to serve the content at the URL that pointed at the logs box rather than the original publisher. And now the problem was that no one knew that the content was in the logs box, so we had to work with the library's normal way of finding journal articles and ebooks, which were DOIs and open URL resolvers. This sounds easy, but it isn't, because the logs boxes crawl the journal and ebook websites, so they end up with an undifferentiated pile of URIs. This process is controlled by a parameterized site-specific plugin encapsulating everything the daemon needs to know in order to crawl the publisher's site. Things like bad times of the week at which to crawl the journal sites, how to define the limits of the crawl and so on. And we use parameters on these plugins to organize the random pile of URIs into what we call AUs, archival units, which typically represent a volume of the journal. But the DOIs and open URLs need to resolve to articles, not to the volume of the issue. So we have to reconstruct the articles from the pile of pieces. And then we have to find the DOI and really rapid metadata that the DOI and open URL resolvers need in this reconstructed article. And so our plugins encapsulate the knowledge needed to do both of these things. They implement an article iterator who knows how to go through an AU and find appropriate pieces of an article. Like you can give me an article iterator for the abstracts of the articles in this volume of the journal. You can tell it to give you an iterator for the full text of each article in the AU. And then the plugin implements a metadata extractor that gives me the appropriate parts of an article, knows how to find various kinds of metadata in it. Now, I prototyped these things, I think about 4 years ago, and haven't worked on the code since. So it's possible that some of what I'm going to tell you is inaccurate, but I'll do my best. So these are the generic classes involved in article iteration. It's pretty simple. There are currently about 56 site-specific article iterator implementations of varying complexity in our collection of plugins. And the most important one is Article Iterator Factory, which is, so you give it an archival unit and a metadata target, which specifies what kind of metadata you want to find in this article, and it will create the appropriate article iterator that will spew out each article in the AU. And now we get to the metadata extraction process. So these are the generic classes that are involved in the metadata extraction process. There are, in the plugin collection at the moment, there are 62 different site-specific metadata extractor implementations which call on these generic capabilities. So here, for example, is the definition of a DOI metadata field. And this is the canonical definition that it uses, and it has a validator in there, which we'll see how we use in a moment. And here's the interface to the metadata extractor, which you give it a collection of article files which have been created by the article iterator and this emitter functor. And the functor will emit article metadata objects describing the metadata for each of the articles. And we get even more of the gritty details, which are that actually publishers are completely inconsistent in the keys, the names that they use for metadata fields. So we have to canonicalize them. We call this process cooking the metadata. The plugin supplies information about how to map from the raw key to the cooked key. What these are saying, what this map is saying in effect, is that if this publisher says that the metadata field is called food, what they really meant to call it was bar. And we store both the raw and the cooked metadata, and we validate the values of the pointed to by the keys as we store them into the cooked form of the metadata. So the raw form has unvalidated field values in it, and the cooked form has validated fields. Here's the process of cooking. You see it takes a multi-map of raw to cook, generates iterates through the set of raw keys, and for each raw key it finds in this article's metadata, it stores the validated value into a set of cooked keys. A set of cooked keys because it may be necessary to map from one raw field into a number of cooked metadata fields. So here's a very simple recipe for cooking metadata, which is the one for Emerald Press journals. And it's saying things like Emerald Press journals have the DOI in a metadata field, metadata entry called citation DOI. So conclusions. Well, we can automatically extract article level bibliographic metadata from crawled websites that's good enough to support both DOI and open URL resolution. And we find that in practice, only infrequently do a few sites hand cleanup. But that's because we've encapsulated in the plugins a whole lot of knowledge about publishing platforms that the various publishers use. It takes quite a bit of the process of introducing a new publisher to the lot system involved going through and developing this knowledge about where to find the metadata and how to cook it. So the current collection of plugins represents quite a lot of work. There are 317 classes implemented in Java, 238 implemented in XML, and almost 700 individual unit tests for this collection. You can do it, whether you can do it for something less restricted than journals is an interesting question. And the final observation is that this is actually an area in which Google has influenced, has had considerable influence. The variability of how publishers represent metadata has decreased substantially since I wrote the prototype. And the reason is that Google Scholar has pretty strict rules about how you have to represent the metadata in order to be indexed in Google Scholar, and publishers have found out that being indexed in Google Scholar is something they need to be, so they need to pay attention to what Google tells them. And as usual, this talk will go up on my blog, so you can find links, for example, to the instructions that Google Scholar provides for publishers about how to put the metadata in their articles. So, questions?
So this was one of the first kind of use case examples of how specific you can be in terms of trying to be able to characterize content that you are pulling in over the web. We're obviously going to talk through a couple of other examples and illustrate that in part of the life cycle. But do you have questions for David on this one? Or on anything else?
I mean, the advantage you have is that you have a certain structure that you can build on, but we still are not able to do an automatic title finding for normal web pages. So it's still needed to have a manual input for the title of the web page for the catalog, because you have the title tag, you have the metadata title, but what is the actual title of the web page? Normally it's welcome or whatever, so that's not helpful for your catalog. So we still would need an intelligent way on automatically finding fitting title of a web page in the web archive.
I think you're misinterpreting my intent in this talk. I'm trying to say that even in the very constrained world of e-journals, doing adequate bibliographic metadata extraction is hard. There's a lot of code in logs behind the interfaces that I'm showing you, and we're doing the easy case, right? But it's possible to do it. We only rarely have to intervene by hand, and we can do what you need to do with bibliographic metadata, which is to do open URL and DOI resolution with pretty high accuracy. So it's possible. It's a lot of work, even in the case where the corpus is pretty constrained.
I have a question. Maybe more of a question for the group, but your last point makes me curious. Is anyone here that has substantial PDF collections, e-journals, whether you're crawling them or getting them from some other channel? Does anyone have those publicly accessible, at least somewhat? Do you allow Google Scholar to crawl them, or do you block that for robots? Do you know? I was just curious if people say, hey, I found your e-journal through Google Scholar. I just don't know if it's happening. I've seen it happen once in one of our collections.
Whether we allow it or not, I don't know.
Yeah.
Ours were exported.
John, did you have something?
Ours were exported.
Yeah.
Very sure that's the case.
But of course, for the normal legal reporters, not allowed to give access on the, to the public. So the metadata of our e-journals are available to Europeana and other aggregators. So that's not a problem. But actually, access is not possible. I don't think Google Scholar is interested just in the metadata.
Most of ours come in through direct channels from major publishers together with the metadata. So we're not using web harvesting and anything like that.
How consistent? Sorry, I just wanted to follow up with Sean. Ask how much reworking in the metadata do you have to do in order to get it into shape from what you get from the publisher?
We have publishers tend to submit with different structures and protocols. So we have metadata transformations to do.
Yeah.
One of the other problem areas is to do with reissues or corrections to articles. So you need to recognize that this is a successor to something else, but the identifier space is not necessarily very consistent. So the match process turns out to be a little complicated for that.
Yeah, I don't think we can claim to do a good job of that.
The other bit of complexity is sometimes identifying, it shows there's a digital version of let's say, a printed classically structured thing. So which issue is it of which journal? And sometimes that's a bit more complicated than it would have been.
Yeah, publisher head print complicates that process.
Well, we have something like 10 million PDFs, maybe 12 million, coming through that channel.
Yeah.
Well, actually, sorry, because I missed the beginning of the presentation, so maybe I missed something you said, sorry about that, but basically, are you saying we could use your connectors and metadata extractors while web crawling so that we can actually gather bibliographical metadata? Is that what your suggestion?
That's what we're doing, but we're doing it in a very constrained, there were very constrained pools, and it's a lot of work because it involves a great deal of site-specific knowledge. So what I'm saying is it can be done. It's a lot of work, even in the best possible environment for it.
It's sort of scale.
Yeah.
Right. But yeah, the point would be that maybe, because we are interested, I think, as web archive, better characterization of web. So I think one thing we could think of actually or talk about is whether we should maintain a larger collectively larger class of connectors current so that actually we can use it maybe expand and what your efforts are because you're targeting some sites. And I guess there's some room you can build connectors easily from cases where so would that the idea would be could we extend this effort collectively so that we maintain some class of extractors for the web archiving community? Does it make sense, or is the idea? Or?
I think, so the other problem is, of course, we're crawling sites that you can't crawl for the most part.
So I think it makes sense we have to figure out for the body of resources so we can do it.
Yeah, so for example, you could reuse our code for OJS journals published on the Open Journal System, because that's open access stuff, and I don't think they put all the traps in. But for the most part, we're calling stuff that's subscription journals that you can't crawl. And so our stuff, I mean, even if we had this wonderful reusable API to it, it wouldn't do you any good because you don't have permission to do what we're doing.
But I think in principle, I think that's a fantastic idea.
Yes.
The more we can collaborate, because this is a great illustration of how much effort goes into tailoring sort of the collection of that type of data from any body of resources. I mean, pick, your government in France, and we're trying to collect specific metadata from each of those resources.
Yeah, so I have two questions. And one is maybe also something I missed about that. How many different connectors do you maintain?
Let me see. I got the numbers in there. There are about 50 of site-specific article visualizers and something around 70 site-specific metadata extractors. And this covers most of, we have, I want to say, something over 500 publishers, journal publishers that have given us permission. And now most of them are covered by article liberators and metadata extractors. The problem is, like all these things, you do the big publishers first, it's a certain amount of work. They tend to be the easiest ones because they're the ones that pay attention to what Google is telling them. And so that the first 10% of the work gets 80% of the coverage, and the remaining stuff rapidly gets down to small publishers who are really not doing very well at paying attention, and for whom all this effort only gets a small number of articles.
And the sequential question would be, do you have an idea of what the fringe of these spaces are and how they are evolving? For instance, do you have an idea of whether microformats or other types of SDFs are propagating, and if they could be useful in the fringe of curated scholarly publishing and extended to open repository, a more loose kind of publishing system? Do you have an idea of these fringes? And
I'm sure the team does. As I said, Chris asked me to talk about this, and this is something that I prototyped a few years ago and haven't worked on since. So I'm sure there are people in the team who could answer that question, but I can't.
Because I think when we do these web crawls, the thing we do more and more at the Memory Foundation is more like trying to systematically extract information so that we can enrich indices, findings in general, or do other processes down the road. And we've done that with detecting data sets, microformats, whatever structure we can get out. So I guess that there could be a nice connection between lots which have been kind of following remotely for a while now. And C4, because I think the interesting space is where there's an extension in these fringes that are proliferating somehow, where your effort could be complemented by efforts from institution doing a larger space around and find where they could apply methods and well curated and organized methods like we have in scholarly condition, and you have extended in distributed archiving to our space, which is the Wild West, but tends to also get some structuring around that and so on. So I think there's an interesting overlap between the two efforts potentially.
Right. It would, for example, it would be easy to extend to add into our framework extraction like the keywords from the metadata and using that to run keyword indexing about the content. We haven't done that, but it's given the framework, it would be easy to do that.
De facto, do you know if, for instance, Google Scholar, I guess, does the official connection to official scholarly publishing, and there also does the web call, leverages web calls? Do you know about that?
I know something about it. So, Vox was sort of a spin-off from Stanford's Highwire Press, and Highwire pioneered not just putting the journals on the web, but also things like Highwire was the first to offer the publishers indexing in Google, and the way they did that was by providing a special route into the journals for the Google crawler. And I know that over time that has evolved away from really crawling the image of the journals that the crawler sees has been specialized to make it easy for Google. But it's only available to Google. And the results, the interesting part of that is the results were spectacular. This was turned on like one journal at a time, and every single one of the journals saw a huge spike in traffic, like about a factor of 10.
So I can give you a specific example. So if you go to Google's UK, Google.co.uk, Scholar, it's Google Scholar UK, search for the words composite manufacturing aerospace. The number 2 hit is a NASA technical report that's in our web archive. So they crawled our web archive, got the technical report PDF, indexed it in Google Scholar UK, and it's the number 2 hit for those particular words. So yeah, so it's definitely happening.
Yeah, exactly. That's why
people are
I find
finding
it very interesting because they managed to actually combine well organized and curated types of access, specific access and content
Well,
access.
and they do emphasize content that isn't available through those official channels anymore. NASA has this horrible habit of pulling things on and offline, and it just so happened that that particular report was unavailable for a period of like 6 or 9 months. It's now back on a NASA web server and actually shows up further down in the results list. But the only reason we're ahead of the NASA capture of it or version of it is because they disappeared it for a while, and Google said, okay, you guys took it offline, so Internet Archive gets to be the record for this particular hub. So they are adapting and they're looking at it, sort of, and they're constantly going out and checking.
Okay, sorry to have given you another rather depressing talk. No. Because I'm just pointing out that doing something we all like to be able to do is actually quite hard work.